Good afternoon, everyone. I'm so excited to be here. My name is Yuval Shchori. I'm the head of product management for CloudGuard, everything cloud security with Checkpoint. I'm excited to be here because it's AWS reInvent, and I'm excited to be here, see people without this square around their faces, not telling them that they're on mute. You are on mute, but any case, really excited to talk about how do we leverage shift left. How do we leverage security to actually effectively shift left? So, Orlando.
I'm Rolando Penez. I am the Global Cloud Engineering Manager. I manage a, you hear me?
Mike? Where's Mike? Is it on?
You hear me? No? Good?
All right. Yeah.
Oh.
This is awesome.
All right. Better?
Yep.
Okay, so I'll start over. Rolando Penez. I'm the Global Cloud Engineering Manager at Checkpoint Software. I manage a team of cloud technology architects focusing on the latest security solutions from Checkpoint and really helping customers automate and learn how to secure their applications at earlier stages, right? And from the development phase all the way down to deployment.
Awesome. Thank you, Orlando. So let's just establish the baseline for today. We're dealing with really complex environments, real complex architectures. And not only they're complex because there are so many different moving cogwheels, right? You have virtual machines, you have infrastructure, you have security, you have firewall, you have kind of tangential system that need to interact and maybe also secure and maintain compliance. You have different type of workloads, containers, serverless functions. Everything need to work in concert. But the thing is that there are different many organizations that are interested in what's happening there, and each of these entities have different types of interests. So for most of the people that actually attend reInvent, developers, DevOps team, it's a lot about just let me develop, let me streamline my process, let me put everything there the fastest I can. But for other teams, again, some of the DevSecOps, the SecOps, it's a lot about let's make sure that we're staying off of the Wall Street Journal headlines, right? It's nothing changed with the shift to the cloud. From a security perspective, the requirements are still the same. When you take a look at the CIO, for example, they don't care about the cogwheels. They care about the application. They care about the availability and the security of everything at the top. Now, throw on top of that the fact that you need to now learn new terms, new capabilities, new constructs that are coming from, for example, AWS. It makes this dance very complex. Everybody is kind of stepping on each other's toes. And again, we need to remember that we have different mindsets of different teams. If you take a look at what's happening from a DevSecOps perspective, they care about automating everything. They want to do, to make sure that everything is in compliance as, just to not move one step right or left from the guardrails that are being, the compliant guardrails. Best practices is a big thing for DevSecOps, right? How do we make sure that the standards are good for us? How do we make sure that we change them if they don't and we create our own best practices? Security is first for the DevSecOps. It's not always the streamlining or productivity. Let's make sure we are secure. Last but not least, the DevSecOps processes are usually discrete in terms of, oh, you're done coding? You're in code freeze? Oh, awesome. Let me take a look at that. And it's not just because how the DevSecOps processes are built or the teams are built. it is because this is how 15, 20 years ago it used to be. It used to be, get things ready, I'm part of the design, but just tell me when you're ready, I'll secure things. And we had time, right? Security people had time. Today, it's something like, I'm ready to go, please secure it, and by the way, we're going live next week. Right? So discrete processes is something that is sometimes kind of not working well, but it is part of the team's DNA. The SecDevOps on the other side, right? Security embedded into the DevOps is, for them, security is almost an abstract concept. It's embedded, it's taking place as they go, it's holistic, nothing is being retrofitted, right? From a SecDevOps mindset, it code it securely, deploy it securely. When you create a container, make sure that the container image is set without vulnerabilities, et cetera, and then comes shift left when you actually say, well, I don't need to do it from a security perspective. I can do it as part of development. Again, when a container is being deployed, I can make sure it's compliant, and I don't need something which is discrete, but instead holistically interleaved into the different process, and not in a specific point in time, but everywhere and anywhere. Now, do we really need to have these different mindsets? Do we really need to have completely different ways of thinking and delivering security? We don't. We can actually collaborate. We can actually strategize. How do we make things, yes, on one hand, with a DevSecOps culture, make sure that you have the guardrails, make sure that you have the best practices, but do it in an intrinsic way. Do it as part of the holistic approach. Define those guardrails in a way that is consumable for DevOps. Make sure that these things are actually embedded into shift left. Shift left is an organizational shift. Don't forget that. It means that a lot of the decisions are being taken by the developers and the DevOps, and not by the security peeps. So you want to make sure that you shift left the security capabilities into the hands of the developers and DevOps. And we'll see a demo, and we'll talk about this quite a lot, why we need this. Last but not least, application security and the overall cloud security. Remember, the cherry at the top is the application. Everything could be secure, but if the application is not secure, you have a problem, because this is like your main vector of attack, because it's your main entrance point. So this is part of making sure that we are bringing together the DevSecOps mindset and the SecDevOps mindset together into a point where we say you have to take care of application security as part of the holistic process. And it's not just something that is external, it's not something that is discrete. Now the question is why it's really important, and why are we talking about this from a developer perspective or from a DevOps perspective? And the reason is that developers are actually actively being targeted today. First, you're human, and when we have human beings, we could use social engineering in order to drag people in a direction they might not have wanted to go. We need to remember that developers have very high credentials usually, definitely on the staging environment, on the development environment, but sometimes it's being carried on to the production environment. And then, if someone actually makes use of that, we're talking about an admin that could do anything in a production environment. Why? Because they are coders. These credentials are usually given because, hey, what's the most important in production? Uptime. If something is down, I want my developer to go and fix the bug, maybe as fast as possible, and change the configuration, right? Developer, DevOps engineer, et cetera, and not always people think about what does it mean if someone hacks into the system. Developer has access, surprisingly, or maybe not so, to source code. And if I could look at the source code, I could identify vulnerabilities, but I could also maybe, in very badly configured environment, plant my own malware inside of the source code. Like, that's the true meaning of a Trojan horse. At the end of the day, again, a lot of capabilities, a lot of permissions. You have data access to everywhere. Usually no one, especially not in development environment, really manages the permissions on the databases, et cetera, et cetera. It's quite open. And if it's kind of copied without a lot of thought into the production environment, we have a huge problem. Also, we need to remember that, and it's strange and it takes time, and Rolando is going to talk about this later on. Actually, the SDLC, the Secure Development Lifecycle we have in place today, has so many entry points, so many attack points, that it is becoming sometimes a burden to secure. It is making the attack surface wider as part of the SDLC itself. Right? So these are things that we have to talk about. So with that, Rolando, take it over.
Thank you, sir. So, in the news, obviously, there's a lot of headlines, and you see them every day. New supply chain attacks, different types of attacks. But, I mean, it's changed, right? I mean, you still have the ransomware. They're still targeting endpoints, right? But at the end of the day, as an attacker, I'm going to look for a simpler way, right? Instead of, there's been so much focus on the endpoint. Instead of attacking the endpoint, what if I go on a different route, right? And so that's kind of what I'm going to talk about now is, some of those examples and really understanding, where this is going, right? So first is understanding the attack surfaces, right? And this is today, okay? I mean, a new workload, now we're in serverless, who knows what comes out, in a few months, right? It's always changing, right? AWS is always introducing new types of technologies, new ways to run your application, okay? But if we look at, today, right, with at a high level, what do we have, right? We have our source code, we have our version control, we have our CI/CD machinery, we have our registry, and then our deployment phase, right? This is typically at a high level how we're building applications today. So I already covered the end user, right, the developer, okay, where that source code is coming from. They're going to do that commit, right? They're going to store that source code somewhere, right? And that version control, that opens up a new attack surface, right? So if an attacker gets access into that repo, right, and modifying that source code, injecting malicious binary into that source code, even though it's best practice not to have a binary in your Git repo, it could happen. Tampering with Dockerfile, right? Docker is very popular now. It's a very quick way to build things, to build your application, and again, modifying that Dockerfile so that it can pull in something that's malicious. Again, it's a very easy thing to do once you gain access to that environment. And then also in the CI/CD machineries, right? So if you're using, you could either be using Jenkins or GitLab or even AWS Code Builder. If there's access into where that YAML file, right, that controls the CI/CD machinery, again, there's areas there where you can modify that YAML file, right, and inject some malicious activity. Okay. Within that CI/CD machinery, right, the vulnerable base image, as you're building that container image, right, that it's, it can, maybe you're pulling in a vulnerable base image, or maybe somebody's injecting something malicious into that base image. There's different ways. You have vulnerable dependencies that you're pulling in for that build, right? So even though you start with that, very simple Alpine base image, right, you're going to need some specific packages, and it's there that you can also introduce some vulnerabilities that can be exploited. And then, again, modifying that image, right, during the build process, okay? Or even attacking the build machine, right? So if you're using your, let's say, Jenkins again, or even any of the other CI/CD tools, GitLab or even Code Builder, the runner, right, where you're executing that pipeline, if those hosts, right, or those nodes are not secure, that can add or that can introduce vulnerabilities into your whole process. And then you've built your container image, right? You've secured that whole area. Now you're storing your container image, okay? What can happen here? Well, tampering with that registry, okay? So tampering, even though you have your private registry, again, if your credentials are stolen, you have access to that registry. Now those images can be modified or tampered with. And then finally to the deployment phase, okay? So as you're pulling in that container image, there's a few things you can do. Either intercept the pull, right? So if you modify the project again and change the URL of the pull request, or even at the deployment. So even that Kubernetes manifest, if you modify that to actually pull a different image, okay? These are all different areas that can be attacked today. And again, it's ever changing, right? It's always going to be changing depending on the new technology that you're using. Okay, so now we'll just dive a little into some real cases here. I'm curious, how many developers do we have? Developers? 2. Security? Okay, and see, this is kind of the problem, right? This is why we gotta, and what we're trying to say is we gotta work together, right? And I'll give you some examples of how that happens. So, Kodakov hack was. Again, very, very powerful tool here. Kodakov is used to do code coverage, right? So how much of your code has actually been tested, okay? And it's very valuable information because the more you test your code, the more bugs you find, the more vulnerabilities you may find, right? So it's a very powerful tool. And what happened here is an attacker was able to find, they're able to find a vulnerability in the Docker image and modify the uploader tool. So it was just the uploader tool, which is used to send the reports into the Kodakov platform, okay? That was modified, and now instead of just sending that report, it was also sending all of the environment variables, right, during the build process. So even though you've done all of this, all the work of securing those tokens, securing your API keys, right? Because this was actually being used during the build process on the runner, it had access to that information. So all that was irrelevant, right? It was getting the environmental information and sending it to a known malicious IP, okay? But again, it's because of this defensive depth, right? And as security folks were always saying, rotate your keys, right? Every little thing that we can think of to ensure that we have this layered approach, right? That's why it helps, and you'll see that in some of the impact, how that was able to save the different projects from actually leaking anything sensitive. Okay, I do want to point out that this was discovered by a user just checking the SHA-SUM of the uploader tool. Okay, so again, it's a simple thing, right, that we usually just disregard. We're like, yeah, whatever, or accept that fingerprint, right? But it was that one scenario where somebody said, oh, you know what, I got to check this, and they found that it was different from the published version, okay? And that's what kicked off the investigation. So the impact, and this is just one example, right? And again, Kodakov is just an example, right? They're going to target developers based on what developers use, what's more popular, okay? And so the impact here was basically, and Twilio is very responsible in disclosing everything that they did, how they investigated this. They did find that a lot of their projects were using that uploader, right? And so they started their investigation. And again, even, GitHub, right? If everybody does their part, GitHub did their own investigation. They actually reported to Twilio, hey, by the way, before we reported this to Kodakov, we found that somebody had used your credentials to clone a repo, okay? So they were actively using those credentials. They were able to get tokens, API keys, access to, think about it, right? How do you build that pipeline? What do you put in that pipeline, right? In those secrets, right? That gives you access to a lot of different things. But again, because of the key rotation, because of all these additional layers of security, right, that are, sometimes are tedious for developers, right? Because again, their focus here is to build, right? Build and get it done quickly, right? Every time we ask them to do something, it's like, you always get that pushback, right? But it's this layered approach, this defense in depth approach that actually was able to save, in this instance, from any further exposure, okay? Another example, of when and how they're targeting users. Okay, so misuse of single sign-on. Okay, and this is from a blog post on Checkpoint Research. You can go to blog.checkpoint.com and read more about it. But in this case, we were able to use. We found that Atlassian was vulnerable on the training URL, right? So using some simple cross-site scripting, we're able to get the credentials for Jira. And then that really gave you, because of single sign-on, that gave you access to all of these different platforms, all these different solutions, right? And so again, there's different things you can do here. There's different areas that you can target, but we're talking about developers. So how can you use this information to target a developer? Well, you go back to, you get this information, you go back to a simple phishing attack. Hey, you open a Jira ticket to a developer, saying, hey, we found something critical in this code. Can you please go and fix it? And you just add a phishing URL into the ticket, right? Developer is going to, let me get this done. Click it, right? That's, they're moving fast. Everybody's moving fast, okay? So again, you can use old school type of attacks by using some of this new information. And then finally, third-party libraries. This is very, very popular now, right? I mean, just substituting what you think as a developer is a legitimate package, right? It could be legitimate, maybe the actual package was attacked, right? Or even typo squatting, right? So, everybody's done it, right? You mistype a URL, right? You go to a website and you're like, oh wait, this is not the one that I typed, right? They're doing the same thing with packages. You're hoping that you import the wrong package name, right? You add an extra character at the end, right? Or that typo squatting. I mean, again, that's old, but it's being used in a new way, right? Because they're targeting developers, and you don't think about it. You're moving fast, right? And who knows? You can even copy and paste, right? You're copy and pasting code. You're moving very, very quickly. So this is another area where we're seeing a lot of activity, right? And again, it's targeting developers because it's very easy. Think about it. You modify one dependency that a lot of different developers are using, you can hit a lot of people at one time, right? And that's easy. It's very simple. Let's see what happens. Let me modify this one, and let's see what happens. Okay, and so we get it. You need to be fast, right? We're trying to develop quickly, right? I mean, the business case is there, right? That's why we're moving to the cloud. We're leveraging cloud resources. You have DevOps. Everything is moving in sync, right? Your developers are moving in sync with your ops team. They're building infrastructure as your developers are building their code. Okay, and we've seen GitHub exploding with different projects. Okay, but again, everybody has to be in sync. And I'll share a little story. I was talking with a customer the other day, and they've been using a tool to scan their dependencies. And you'll see, I'll talk about shift left in a second and what we do with shift left. But basically, shift left is going beyond just the vulnerabilities, right? We're not just looking at the vulnerabilities in the dependencies. We're actually going into looking for IPs and URLs that can be malicious. But our scan was taking like a few minutes longer, right? And the security team came back to us like, hey, the developers don't want to use this because the build time is taking longer. Is there any way you can tone back the security a little bit? Right? And I'm thinking, I'm like, you do realize what you're asking me here, right? But I mean, that's the conflict we're running into, right? We all got to be in sync. We know they got to move fast, but really, a couple of minutes here, a couple of minutes there, I get it. It can get really long. But again, it's just getting into that same mindset between developers and security that's really going to get to a good point, right? Where you're going to get security, either in a layered approach, right? By using these different tools and just talking, just communicating, right? Getting the right requirements between the two teams.
So how do we solve this? We solve this, as I said earlier, by ensuring that everything contains something security. Security has to be holistic to the process. Security has to be everywhere. Starting from developing, pushing into the CI/CD pipeline with security integrated, right? Our shift left tool, but again, I'm not trying to sell here. I'm trying just to talk about like what do we need to do. Next is security in the CI/CD pipeline itself, right? So as part of securing the pipeline itself, but also make sure that when things run through the CI/CD, different stages, right? You have those checkpoints, no pun intended, of, well, maybe a little bit intended, inside the CI/CD pipeline and also inside the process. I'll give you an example. One of the things that we really preach is it's not enough to make sure that your container repository contains clean images, right, that have been blessed by the chief priest, the high priest of security, right? You want to make sure that when you take an image and make it part of the deployment, go into production, you want to employ some kind of access control, not access control, what's the word I'm missing? Admission control, sorry. Admission control from the registry, from the repository into production, right? You need to make sure that when you are deploying these things, you also make sure that, yes, it's still the same thing, nothing changed, no one inserted any new vulnerability, etc. And you want to make it automated. One of the internal slangs, or not slangs, like one of the buzzwords we have inside, right, is it ain't done until it's automated, right? We want to make sure that we automate as much as possible in order to allow enough time for the developers, for the DevOps, to focus really on what they need to focus on. And we need to remember that if we give someone 10,000 findings for a single image, it's going to be useless, even if we prioritize. We need to make sure that the things that we could fix are being fixed automatically, right? You want to make sure that you're not relying on the fact that you're handing your developer or DevOps team, a 50 pages long report which they need to go one by one and fix things. You want to try and automate as much as possible. Some of the automation, by the way, is prevention. Oh, this image has not been blessed. It does not abide to the security policy, to the same guardrails that we talked about. It is not going to go into production. Of course, the security automation is different post-production, right? I'm not sure I'm going to, well, not today at least, I'm not sure I'm going to tell a customer, well, your remediation, your automatic remediation should be pulling an image in production if it has an issue. Probably not, because that's too much of an impact, right? We want to make sure that, in a way, we want to have some job security, so not every time there's a security issue you want to pull a container off production. At the same time, you do want to employ different mechanisms, like workload runtime protection, just to protect against a specific attack in an automated manner, and not something that requires manual intervention. In the different stages, within the different milestones of the workload and VM lifecycle, you would want to employ different types of automation capabilities, right? Pre-production, you could be a little bit stricter. Post-production, you want to be very pinpointed, and you want to be able to automate things, again, very specifically against a specific attack. So the question is, all right, when the rubber meets the road, tomorrow, maybe not tomorrow, next week when you're back in the office or in your home office, what do you do? What do you focus on? Some of these things are very well-known items on every security person list. But since, again, we do have a good amount of developers here, I think it's critical for everyone to understand this. If this list is going to stay a security people laundry list, it is going to stay unusable. One thing which is crystal clear is focusing on what's called the OWASP top 10, right? It's because most of what we see today is web interfaces being both the end user interface and and also the supplier, the partner interface, end user from a browser perspective, supplier from an API. Again, think about digital transformation and automation, the ability to automate everything through API. You want to make sure that these interfaces, those web interfaces, are not easily penetrated, right? You want to make sure that you're putting the right guardrails to ensure that those OWASP top 10 are being stopped as soon as possible. You want to make sure that you're hardening authentication. You're always using MFA, and you restrict from which IP addresses SSO is being permitted. So, for example, if your company uses some sort of VPN and you're working from home, great. Let's make sure that we're allowing just this IP block of the VPN remote access block to use SSO in order to elevate permissions or receive whatever permissions on the system. Again, not as a user, as an operator, as an admin, et cetera, et cetera. Least privilege. Least privilege is very easy to say that. It's not that easy to employ. There are products in the space. I'm not supposed to sell anything, I'm not, that use AI, that use machine learning in order to look at code and actually help developers and DevOps understand what is the least permission model they could use, right? We see tons of, for example, I think the most evident example is S3 buckets that are configured with full read-write on everything to, everything. It works, right? The first law of IT is don't fix what ain't broken. If it works, let's not change the permissions. However, if someone does get access into your serverless function or gets access into your container, actually they could use it in order to plant malicious code for the use of other places and use it as a jump board. And you want to make sure that you have the tools that do not require you to go manually through the code, but instead, remember, automate everything, right? You want to make sure that in an automated, a la machine learning and AI perspective, you want to make sure that you're given the permission, the permission model that is relevant for the serverless function. Auditing. Make sure that everything is being audited. And it's not just for the sake of, yeah, I got it, it's written somewhere, but all the changes need to be audited. And when you deploy, when you commit, you want to make sure when something changed, right? Rolando talked about the fact that a hash changed on a script, something that could have been prevented if there was something that said, well, actually, I have 2 lines, one doesn't match. Right? It makes sense to maybe look into it. Authentication information, secrets, hard-coded API secrets and keys within the code. Again, you want to make sure that pre-deployment there is something that tells you, hey, you forgot a secret in the code. You forgot a backdoor that someone, if they gain access to the source code, they could actually do a lot more damage because they have secrets to other places. We talked about automation, so you have it also from a provisioning perspective. You want to make sure that when a user leaves, for example, the organization, you want to automatically deprovision whatever permissions they have into the system, right? And never use like a static password that kind of, if someone still remembers it, they could use. And there are companies where people were let go, were fired, and they, resented and they, kind of attacked the organization. I remember there was a WebEx attack, I think a year and a half ago, where an employee that got fired actually deleted hundreds of servers of WebEx services, right? We want to make sure that this cannot happen by deprovisioning automatically. We talked about auditing. You can't say audit enough. It has to be, things have to be written down. And also make sure that you have those embedded capabilities like, branch protection, embedded capabilities within the system. So actually, can everyone access a specific branch? Maybe it's just for more senior developers, right? Maybe it's just for people that are supposed to touch, the production branch or whatever specific branch that you're trying to overprotect. And eventually, monitor critical code. Check the hashes. Make sure that nothing changes, especially where you know that you have a code that is exposed. Someone can access it, right, or trigger it, and make sure that this is being monitored. This is, only 9 things that you need to keep, right? All of them are doable. We're not asking, someone to do something that is going to delay them for years or months or weeks or days. It's something that could be embedded in the process. Now, in order to see what success looks like, I'm going to hand off back to Rolando, but I want you to remember that it's not far-fetched. It's not something that we have customers who are in a very good situation because they kept all this, all these secrets of the trade and made sure that things are being done as needed and as required.
Yeah, so what does success look like? And, again, this could be a little overwhelming, right? This is really the approach that Checkpoint's taking, right? Both internally and for our customers, okay? We understand there's different areas now that need to be secured. And so we're trying to extend our platform to be able to accomplish that, okay? So, from the developer standpoint, right? Because again, how do you get to the SecDevOps or DevSecOps mentality? It really is where your developers are now contributing, right, to security, okay? They're either, they understand, how to scan their code, right? I mean, they scan their code today for certain, they do linting, right? There's some things that they're already used to. Why couldn't they extend that into security, right? And so we're looking into those different areas. We're trying to expand our security, our threat intelligence data lake. How can we use that in all of these different areas moving forward? As AWS introduces new platforms, new features, what is it that Checkpoint can do? How can we leverage this very powerful threat intelligence and integrate it into these other areas? Okay, and so today, we have a variety of different solutions that can, interact with other vendors, interact with AWS, and that's really the goal here, right? It's not just Checkpoint; it's across the board. It's being able to integrate with different solutions, right? I mean, one security vendor is not going to be able to do everything, and we understand that, we get that, right? But it's how can we integrate? How can we make it easier for you, because you're using these tools, because you're already, you have your process set up, how can we help you? How can we expand our security solutions into your environment? So with that, I'm going to jump into a quick demo. And this demo is Shift Left. Okay, so Shift Left is one of our newer solutions. Again, we're taking the our threat intelligence data lake to help secure your pipelines. And we're trying to demonstrate this from the software developer's point of view, okay? And we're going to be using, in this case, we're going to be using GitLab. So we'll start with a simple Git repo. It contains all of our source code, our Git the GitLab YAML, the Terraform scripts, right? Just a basic project, right? That has everything from from the application out to the deployment. And so with GitLab or any other pipeline tool, right, you have your YAML file, and we have 3 stages in this case. We're going to leverage the Checkpoint Shift Left Docker image to actually execute the different features. Our first feature is the code scan feature, okay? So you can see how we're calling the code scan feature from here. And code scan, like I said earlier, it's beyond just your standard vulnerability scanning. We're actually looking for malicious IPs and URLs. We're looking for sensitive code, for example, code that's susceptible to cross-site scripting or SQL injection attacks. We're looking at the vulnerable images or the vulnerable dependencies, and then also any binary that leaks into the repo. We're using the latest hashes from our threat intelligence to be able to scan those binaries, right? Even though it's best practice not to have any binaries in your repo. Okay. Again, just with Checkpoint, what we always try to do is limit your risk. Okay, so when we do this code scan and when we do the container image scan, we're all doing it locally, either on the runner or on the endpoint. okay? So we're leveraging just the metadata. We're only sending metadata. We're only sending IPs and URLs. We're only sending the SHA-256 hash of those binaries, and that's what we're using to keep track of, or to scan the different files that we find. The next stage is the image scan. So we've already scanned the source code. We're going to take that base image. We're going to scan the base image for any known vulnerabilities, right? We're just, again, we're trying to find anything that leaks into the process and, you know, be able to secure it in that stage. The last one is the infrastructure as code assessment, okay? So today, actually, we support CloudFormation and Terraform. But with this tool, we're able to actually enforce CIS posture assessment early on during the development process, right? So, you know, we can keep things in sync before they actually get deployed into the AWS infrastructure. So we're going to take this code, we're going to do a commit, we're going to push it into the repo, and then we'll have the repo trigger our GitLab pipeline and actually start going through all of these different stages. Okay, so you can see all of our different stages, right? We have the 5 stages that we've built out in our environment. We have the code scan, okay? We have the build stage for the container image, and then we have the image scan, right? And then finally the infrastructure as code scan at the end. Okay, so we've kicked it off, but we see there's an error here in the code scan. So let's dive into this code scan and see what was found, all right? First thing you'll notice is that the tool automatically updates. You can also pin the version, like if you need to promote from staging to development, right? You need to be able to pin the version of shift left that you want to use. We can see the first finding is actually an IP of 0.0.0.0, which is, in that context, it allows everything, right? In this case, it's allowing all interfaces into a security group, right? And so that's this is kind of the information that we're finding. Content, right? A hard-coded password. Then we're looking at the file reputations as well. So we can, in this case, we find that there's a malware, there's a malicious binary here. Give you the path where it's located. And again, this is how we're taking advantage of our threat intelligence to find that information within the code scan. So we've fixed everything, right? Our code scan's checked off. We've built the image. You know, the other 2 stages really just saving information around the build stage of that container image. And then we get to the image scan, and we found errors in this stage now. Okay, so here we have, again, our action is blocked, so that's why we've stopped the build process. We can see some of the findings here. We have package findings, and then we have the file reputation. Okay, and in this case, we've in the build stage. So this is aside from the source code. In the container image, we've seen that some way they've actually injected some malicious binaries into the container image, into the Docker image. So we can use this information. What we'll do now is we'll jump into kind of the UI and show what it is that we're finding. So you can see all the information that we're actually generating. And again, from the security standpoint, right, this is very valuable information to understand how the build process works. The layer information we'll use to see how the actual package got injected into the container image. Any finding that has a remediation will have the information, right, so that you can start remediating those. And many times, one remediation will resolve a lot of CVEs. But again, we will address those during the scan. Okay. So we're going to take that, as I said, the layer information, and we're going to use that to find out exactly how this build process, or how the container image got those files injected in there. So with this simple tool, this open source tool, we're able to see the different layers and how each layer manipulates the container image, and we can find that this specific layer, which matches our reporting, right, is where the actual package or the actual file was injected. Okay, so we can see that we didn't we installed this actual package, and that's what caused that vulnerability. We go further down, as we found those different malicious binaries, you can see that again the layer information, right, matches what was reported in our findings. Okay, so again this layer information is very valuable. to help you find. And now we can use the Git information to correlate that and determine how all of this happened, right, to further the investigation of these vulnerabilities. Okay, and the last stage is going to be on the infrastructure as code assessment. Let this lag here a second. At the end, we are going to do some Q&A, so if you want to stick around, I'll be happy to answer some questions. And also, you can see some of this in action at our booth. What was the booth number?
1004.
1004. Okay, so the last stage, again, we're going to fix the image scan. Actually, we're just going to allow it through. The infrastructure as code assessment. This actually leverages our posture management that we have today. And basically, again, we're trying to extend that capability into your pipeline. So it uses the GSL rule set, and so we have specific rule sets for Terraform. And you can see how you can build a rule for Terraform by using the GSL builder. Again, GSL is our global security language that we use to build all of our posture management rules. So in this case, we have the Terraform AWS CIS foundations, okay? And you can see all of the different rules. We're going to continue to build additional rule sets and really expand the solution to cover more frameworks, more security frameworks. So in this case, we ran the assessment. We pointed it to the corresponding rule set. We found that there are some S3 buckets that are misconfigured. So we can use the rule set to understand what exactly is it that we need to remediate. How do we fix this remediation? Okay, so we can just search for S3 buckets in this case, find the rules associated, right? Again, within the rule description, we have the description, the remediation, and all the information you need to fix this within your Terraform project. Okay, and again, this is part of our platform. You can be used as a standalone on a developer's machine. We are working on IDE integrations for VS Code and other solutions. And again, we're trying to help promote this DevSecOps or SecDevOps mentality to our developers. All right. With that, I'm going to give you my final thoughts on how Check Point is approaching, all these changes that are coming. Right? Again, layered approach, defense in depth, very simple engineering concept, right? Divide and conquer. All right? Like we did a data center, now we got to apply it to your development process, okay? Because things have changed. You saw they're using typo squatting now for your packages, right? So it's an old attack method, but it's being used in a new area, okay? And again, how we protected in that area again was a layered approach, right? Defense in depth approach. Okay, and there's a variety of tools out there that can help you do this, right? This is our thought process. You leverage that, get in sync with your teams, with your development teams, and try to promote that SecDevOps and DevSecOps mindset. Your thoughts there, Yuval?
Thank you, Rolando. So my final thoughts are that, when I handed off to Rolando the first time, you actually saw the SDLC process, right? And you saw how does it look and all the attack vectors or all the entry points for attackers. I think that in the demo, you saw in action that these entry points are actually exploitable. And that's exactly what we saw in the demo, right? The ability to use different points in the lifecycle of code and applications and workloads within the cloud in order to attack the entirety of the cloud architecture. It's critical for us, and if there's something I really appreciate is the fact that we saw, over quite a number of developers raising their hands. We have to, from a security perspective, we have to really shift security left, right? And the ability for a security engineer, right, or a compliance engineer to write a security compliance policy and a DevOps engineer run the IAC assessment as we saw, using the same language, the same policy, and just receiving just the deltas between what the guardrails are and what the actual code is being deployed, for me, And for us, it's a great thing, right? We're speaking, we're actually, so the recommendations, the remediation recommendations are spoken in the language of the DevOps and the developers, right? In order to make sure that we are providing them with the tools, not just, hey, your S3 buckets are broken, go fix it. But instead, this is what you need to do in order to fix it. And in other, we did not want to really elongate too much the demo, but in other places where it's relevant, the system could actually give you the YAML file. You could grab, copy, and paste into your ISC environment in order to just fix what's broken. For example, if you remember, I talked about the S3 bucket, which is overly permissive. If we find it, we can give you like, these are the permissions that you need. This is what the system requires. These are just examples of how to effectively pull security into the left side of the equation, the left side of the organization, where the code happens, where the DevOps deploy these machines. If there's one thing I would really like all of you to take from this session is that security cannot happen at the end of the development road or journey. It has to be pulled left. It has to be shifted left. And I think that we showed you some examples how to do it. If you download this presentation, tons of helpful resources. Here, tons of links. If you want to look at some of the attacks that Rolando talked about, you have some of this information in just Google Checkpoint Research blogs or blogs.checkpoint.com, and it's there. If you are interested in hearing more, either sign up for a virtual security assessment. You can also visit us in the expo booth, in the expo area, where booth 1004, when you walk into the expo, it's just on your right. You can't miss the pinky, the pink colors of the logo, and Rolando's shirts and socks. Thank you for that. One additional thing, you could come to the booth and play with the AWS Jam, a game where you actually we gamified the workload security stuff. You can also access it online. So with that, if there are any questions, Nathalie is here, running around ready. There's a question here. Yeah, we're working out the steps number that you're going to have.
My question is, what programming languages does the CodeScan support?
Great question. So because we're looking at patterns, right, and all these algorithms are run locally on the runner or on the machine, right, where you execute shift left. So the algorithms are just looking for specific types of patterns, right? And so those patterns really match any language, okay? So we're not limited to a specific language. Again, we're trying to put all the security context that we can into the files that we see. So we're scanning shell scripts, we're scanning the actual source code, and even in the demo you saw that it actually found that 0.0.0 IP address in a Terraform file, even though it wasn't doing the infrastructure as code assessment yet, right? So we're taking any security context and using that to scan those files.
Okay, thanks.
Any other questions?
Uh-oh, I know this guy.
Sorry. Regarding supply chain attacks and checksums, is there any built-in functionality for that in Shift Left? For example, do you keep a database of valid checksums? And is there any recursive function in Shift Left that can identify binaries and do checksum checks on them, basically?
We're not matching the checksums to the published checksums. We are matching, we're leveraging our latest hashes that are known malware binaries, okay? Yes, yeah, we use our own technologies to find those indicators and then act on it.
Thank you.
Yeah. And by the way, every tool out there has their own way of verifying, right? And Kodakov, after this attack, they actually updated a lot of their documentation to reflect that on how to properly check the SHA-SUM. All right.
Got a question. Does Checkpoint allow you to put quality gates on when it finds things instead of allowing the developer to skip on certain things that it finds or recommendations?
Could you repeat the question?
Yeah, so as it's going, let's say, for example, you integrate it with a CI/CD pipeline, and as a developer commits code into a repo and runs through a CI/CD process, if Checkpoints finds any vulnerabilities, can you set quality gates on that vulnerability so that a developer is not able to just bypass them, say, oh yeah, that's not a big deal, I can go ahead
Yes,
with
absolutely. So there's really shift left, there's two ways we use it. And again, shift left is something we use internally, but basically you can use it in the pipeline standalone, or you can actually integrate it back into the CloudGuard platform, the CloudGuard UI, where the security teams would have visibility into the builds. And so as those alerts come in, that's where you would apply the exclusions or allow the build to continue. So if you tie it back to the UI and are actually using it as part of your process, then the security team could control how the different alerts are either bypassed or addressed.
Thank you.
Anyone else?
I believe you said that at one stage you're scanning the image, and I was wondering, do you scan for compliance levels like CIS or DISA at all, possibly like replacing what Amazon Inspector might do?
Yeah, so that's really scanning more of the Docker file itself, right? The standards of the Docker file. That is something that we're looking to do, but currently our approach is strictly in the security context, right? So again, all of these threat indicators, right? How can we use it to scan that container image? Not really on the compliance side, where it is something that we're looking to be able to scan the Docker files and scan YAML files for compliance or for setting those guardrails. Right?
Yeah, over here. So this might be a kind of specific question, but it's awesome that you guys have threat intelligence integrations, but of course we have the problem of polymorphic malware out in the wild. So let's say in our container image, there is polymorphic malware that will change its own hash. Even out in the wild, that they slip through the cracks all the time, it happens. However, would you guys have any faith in crowdsourcing threat intelligence so that if a customer picks up on polymorphic malware within their repositories or containers, they're able to submit it to CloudGuard so that you guys can have better visibility and scanning for other types of malware?
It's definitely something we can consider. The hash is really just one indicator, right? There's a lot of other activity that binary, malicious binary, is going to do.
Of course.
Yeah, I mean, we're always open to looking at how we can use other resources.
And maybe to add to this, I think it's also a matter of, maybe I'll call it market maturity. Crowdsourcing is a great way. However, sometimes when you do things automatically, customers are a little bit kind of concerned about, do I really want to use everything? Do I want to look at something which has been, fully blessed by a company, by someone I could, hold their throats and choke it really hard if they're doing something wrong? Or can I trust something which is crowdsourced? Mm-hmm. I think that in where we are today in the market, again, for those of you who are, I won't call old, I'm old, but I remember when the market started to transition from IDSs to IPSs, right? No one uses IDSs today, right? But there was a very long time, almost I think 12 years, where IDSs were the only thing used. No one even thought about, really preventing something on the wire. It took time until, people started trusting it. I believe that with crowdsourcing, hashing and attack signatures, et cetera, I'm not sure that we're 100% there. We see it, by the way, in the IPS world, we have, there's Snort, which is completely open source. Everybody uses it. There's their enterprise, their enterprise flavor. It's still, I think, in the cloud space, it will be required to mature prior to the market using it. And I think that we have the constructs. So once we want to introduce additional threat feeds, et cetera, it's something that we could do once customers ask for it.
Thank you.
Any additional questions?
So how are we on time? I just want to be sensitive for the next session. Are we,
Excellent.
any other questions? Oh, all right. Well, thank you for attending, everyone. Really appreciate it.
Thank you, everyone. Thank you for staying. Do not forget to complete the session survey. Thank you very much.